Okay, so this video is going to be sort of a continuation of section 3.5. Ultimately, we're going to be talking about domain and range of graphs, but I want to include the bell ringer that I normally do right after what we went over in 3.5 so far. So included in this video is this bell ringer that we probably did or are going to do in class. So this worksheet overall, the whole idea here is it's always these questions. What is the domain of the relation? What is the range of the relation? And does this relation represent a function? Does it qualify as a function? And throughout this bell ringer, we deal with, how easy is it, or how do you answer these questions when you're given a list of ordered pairs, when you're given a table that represents a relation, a mapping diagram, a graph, here's another graph, or an equation. So there's all these about 5 different situations where you can be given a relation almost like in 5 different ways and need to answer these questions. And I guess you can already see the emojis as we skim through there. And this is something that you probably already are picking up on from the previous lesson or 3.5 so far. Some of these questions some of these situations are way easier than others. So just quickly going through this, and by all means, if you want to pause the video, and if you have this paper, or if you want to pause as I move from question to question, keep pausing to kind of try to figure it out for yourself, please. But so remember, the domain is just all the x's. So in a list, the x coordinates it's always the first coordinate. So the 1, the -2, the -3, the -1. It's just like a list of all the x's just listed separately. And the range is all the y coordinates. So the 2, the 4, the 2 again, but you don't need to list the 2 again. The -4, the 5, and then the 3, which you don't need to list 3 twice. So again, domain and range is just all the x's and then all the y values. And I don't think this is something I've said in a video yet. I mean, correct me if I'm wrong, but oftentimes in these lists of hey, here's the set of the domain values, and oftentimes they put these numbers in numerical order from smallest to largest. Like I would imagine if you're looking at some multiple choice options on the keystones, and you're looking at, okay, which is the domain? What set of x values represents the true domain? You're going to see all the choices listed in order, in numerical order. And then remember, here's the next question. Is the relation a function? Again, an easy question to answer. That's why these little emojis are smiling, because they're very happy with how easy this is when you're given a list of ordered pairs. So, because all you have to do is look at the x coordinates and see whether or not there's any repeats, because as long as there's no repeat x's, then it qualifies as a function. A function, you're not allowed to have, for every x, there's only one y in a function. And one way to translate that is there's no repeat x's. So this, given a list, easy. Given a table, and I think I said this in the last video, somehow even easier. Where you could have, I don't know, double smiley face, I don't know. Because again, the domain is just all the x's, and it's separated already for you in 2 columns. The range is just all the y's. And again, you don't need to list repeat, numbers twice. And again, you could put these numbers in order in each list and probably have a better answer than what I have. And then is the relation a function? Well, are there any repeat x's? There is. So then it's not a function. Number 3, this is a mapping diagram, which again, it's not really that different from, a table or something, because here's all your x's and here's all your y's, and the way you're going to be able to tell, so there's all the x's and y's are easy, so super easy. And then this is pretty much also easy. It's maybe a little bit tougher than a list or a table, because you have to look at the arrows and be able to understand that, like, oh, like right here, this double arrow coming off of the 3, that means there was a repeat 3, because this x equals 3, this x value of 3 is mapping to both the -1 as a y value with it, but it's also going to 5. So like if this was in a table or a list, you would see like 3 comma -1, but you would also see 3 comma 5. So I mean, maybe not as easy. Smaller smiley face. Well, number 4 and number 5, this is where things get a little bit trickier, okay? And it's on the bell ringer because I wanted this to be comprehensive, but we don't know how to do this one yet. And by the way, we certainly don't know how to do number 6, or at least I've never talked about it with you. So we're actually going to skip, for now, 4a and 4b, as well as 5a and 5b. But we did talk about in the last video or the last lesson so far in 3.5, how to tell whether this represents a function. Remember the vertical line test? So if I do the vertical line test on this graph, it seems like any vertical line I would draw, or as I move my finger or pencil left and right, it's only ever hitting the graph in one spot. So that would be a yes. Okay? And then for number 5, likewise, 5c, is this relation a function? Again, maybe it's not as easy as the other easy questions, but it's still pretty easy. But you see how like this vertical line is hitting the graph twice? It's hitting it twice. It's hitting it twice all over the place, except for right there. It's like clipping it in only one spot, but it's hitting it twice. All it takes is one vertical line to hit the graph in more than one spot. So that'd be a no. And then some interesting emojis here. We're not really going to include this. I mean, I suppose it's possible I could throw this as a random bonus question somewhere. I don't know, no promises or anything. But figuring out the domain of this when it's represented by an equation, that can be tricky, and then arguably even worse, usually, what's the range of something, when you're looking at it as a equation, being able to tell what the range is, what the set of all y values would be, as well as, like, back with the domain, the set of all possible x values. I mean, I'm not saying you can't do it, but we might not get into that. And it's usually probably tougher, in my opinion, the toughest kinds of questions. This question, I don't know what that emoji usually means, but it's still not easy. Remember, a function is when if you input an x, or for every x, there's only going to be one value of y that goes with it. So if you plugged in any number for x, like pick any number, it doesn't matter. Like no matter what number you plug in for x, is it possible for is there any number that if you plugged it in, you could end up, like y could end up equaling more than one answer? do you think? Like if you plugged in 0 for x, wouldn't y only possibly equal one thing? Yeah, if you plugged in a negative number for x, like -3, aren't you only going to get one answer for y? Yeah, so far so good. Decimal, yeah, I mean, so no matter what kind of number, no matter what number you plug in for x, so I can tell you right now the answer here is yes. Remember I said in the last video, or possibly in person, in class, like it's very easy for an equation with x and y to represent a function, to kind of satisfy the stipulation, the requirements for it being a function. For every x there's one y. Alright, so unfortunately we have to leave this bell ringer kind of incomplete for now. And again, the majority of this video is going to be dealing with domain and range of a graph. Okay, we have to really unpack this. So bear with me as we first start with this, which actually is from the 3.5 notes. So in your 3.5 notes, if you want to write some stuff down, it's this part that we skipped. So in the 3.5 notes, I think we're basically talking about at least this graph, maybe even this graph as well, but that's what we're going to be looking at. So ready? Here we go. So keep in mind that obviously the definition of domain and range matter, like that's almost everything. So remember, the domain is nothing more than all the x values involved. The range is all of the y values involved. But with a graph like this, when you're thinking about all the different x's, like is 0 in the domain? Is there like, does this graph use any points where like x equals 0? Yeah. In fact, 2 of them. So because of these points, or just either one of them really, is all it takes is 1 point. 0 is in the domain. Okay, by the way, 5. That makes 5 in the range, as well as -5 is included in the range. Is 1 in the domain? Does the x value of 1, is that involved on this graph? Yeah. Right here and right here. And you could approximate what that is, like 1 comma, I don't know, 4.2-ish, whatever it is. It is obvious that 1 is in the domain because of like those points. How about 2? Is 2 in the domain? X equals 2? Yeah. Because of that point right there. We have like one of the points represented on this graph is 2, 0. So yeah, 2's in the domain. What other values are in the domain, if any? I think we did 0, 1, and 2. And you might be thinking, well, also -1, because like there's a couple points where x would equal -1, and there's a point right here where x would equal -2, right? Would there be any others? I mean, are those points... Here, let me grab this. Bam. Okay, and then so like for like the x equals 1, and then a couple of these points for x equals 0, and then a couple of these points for x equals -1. Like, are those, 8 points? Are these 8 points like the only points on this graph? Heck no! Is -1 in the domain? Yeah, -1's in the domain. Is -2 in the domain? Yeah. Is 3 in the domain? Would there be any points on this graph where it's 3 comma something? No. So if you want to put no right here, is 1.5 in the domain? Like, are there any points where the x-coordinate would be 1.5? Yeah, like right there and right here ish. You know? Like this would be 1.5 comma, I don't know, about 3.5. And how about 1.9? Is 1.9 in the domain? Like, is there a point where it's going to be like 1.9 comma something? Yeah. And then 1.9. Anyway, hopefully the point is, no pun intended, the point is, like, what are we getting at? There is an infinite number of values in this domain because there's an infinite number of points. Okay? And also for the range, by the way. So how are we going to say that? Like, we can't, like going back here, we can't make a list, because it's a never-ending list. So how do we go about describing the domain and the range when it's an endless list of numbers? So here's what we have to do. So there's also this paper that hopefully you have. It's like set notation versus interval notation. So there's going to be certain ways we write out, or we can kind of write what the domain is and what the range is. And we're going to have to use notations like this. Hopefully you recognize this kind of stuff, where x is greater than or equal to -3, or x is less than 6, or y is greater than -2, because these represent an endless, infinite set of numbers. This is an infinite set. It's just like literally everything that's greater than or equal to -3. That's -3, that's -2, that's -1, that's 0. It's also all the decimals. It's not just the nice integers. But anyway, so hopefully this looks kind of familiar. I hope. And this right here, this fancy looking R, is a symbol that we use to just shorthand, for those mathematicians are lazy sometimes, but smart. Remember, work smarter, not harder. That represents all real numbers, because sometimes the domain includes literally every real number, as well as that could be the range. The range can sometimes literally include every number, all of them. Anyway, so let's talk about interval notation. So another way to write this, all x's greater than or equal to -3, is that. This is saying the same thing. This is saying, from -3 to infinity and everything in between. Okay? This right here, domain, all x's less than 6, can be said like this. And I know it looks like coordinates, but if it's in the context of this situation, and if it's meant to be interval notation, these aren't coordinates, it's an interval. It's like from -infinity, that's right, -infinity, all the way to 6 and everything in between. This right here, if you remember, is like everything in between 4 and 7. Okay? What do you think the interval notation would be for literally all real numbers? That's right. -infinity to +infinity, with everything included in between. This one, a range of everything, all the y values that are greater than -2. What do you think? Everything greater than -2. From -2 to infinity. And I don't know, maybe by now you're noticing, ooh, sometimes we have parentheses and sometimes we have brackets. Is that on purpose? Is there anything to that? Yep. We'll talk about that in a second. But first, this final domain in navy blue. We are Penn State. All x is less than or equal to 5. Everything that's less than or equal to 5, well, that would be from negative infinity to 5. And what do you think the significance is of the brackets versus the parentheses? Take a look at like the symbols over here with the greater than or equal to, less than or equal to, because that's what matters, okay? Essentially, if there's a bracket, that means like it's from negative 3 and on up to through positive infinity, but we're also including negative 3. Okay, down here it's from negative infinity to 5, and we're including 5 in the list, because it's like it's not just everything less than 5, it's everything less than or equal to 5. We need brackets here because it's like y is greater than or equal to 4. It could equal 4, and then yeah, everything less than 7 at the same time, but also or equal to 7. So 7's included. But when it's simply something like all x is just less than 6, strictly less than 6. That means like what is 6 in that list? No. But how else can you say this? Because guess what? Not only like it's not just 5. Like what's the biggest number in this set? It's not 6, because like 6 isn't included. And guess what? It's not 5, because we can also include numbers like 5.9 and 5.99 and like 5.9999999. So this is how we represent that. You know, we're going all the way to 6, but we're just not including 6. And this is how we kind of say that we're including numbers like 5.9999999. Okay? Alright, so let's go back to our 3.5 notes. Get some answers down for these two examples. So, domain and range of this graph. So if you had to describe or all of the different x values, wouldn't it be, you know, like you'd have to say what its smallest x value was, like how far left does this graph go, all the way to how far right. So from its smallest x value to its largest x value. So like its left to right coverage. So you would say from -2, for all x's from -2 all the way to +2 are utilized on this graph. And then the other way to write that, so this would be interval notation. This would be the other way you could write it. You don't have to do both. This is another way. This is set notation. And then with the range is now all the y's. So it's like if there's an infinite number of coordinates with an infinite number of y values with y, or infinite number of points with an infinite number of y coordinates, you have to kind of do an interval kind of thing from the lowest y value, you know, like how low does the graph go, to how high does the graph go. So this range would be all the y values from y equals -5 all the way to y equals 5 and everything in between. Likewise, this graph over here, you know, you think like for all of the x values, you know, from the smallest x value to the largest x value. In other words, how far left does this graph go? Like right here. So like what's the furthest left x value? -6 apparently. And then how far right does the graph go, or does the graph go to the right forever? It doesn't go to the right forever. It only goes as far right as right here. And then what's that largest x coordinate there? 1. So that's interval notation. That's set notation. And the range, remember, the range is only the y coordinate. So it's like, how low does the graph go, or does it go down forever? No, it only goes as far down as right here. And like, what is the y value there? So like, look at the y-axis. And then how high does the graph go? Like, does it go up forever? No, that's the highest spot right there. And what would be the y coordinate at that highest spot? In other words, what's the largest y coordinate on this graph? 5. So those two examples are very, very similar. But, oops, and then there's also that, of course. So again, pause the video if needed. I think the only thing left to do in the video is to do these examples. So again, hopefully you have this paper with you. This would be, let's see here. Examples, domain. So your paper would look like this. Hopefully you have a copy of this. Section 3.5 continued. More examples. So there's 7 examples that hopefully we can do really quick. Starting with this first one, which, looks a little different, I guess, but this is actually the easiest, arguably, kind of graph if I want the domain and range, because this graph actually doesn't have an endless number of points. There's only so many of them. There's only 1, 2, 3, 4, 5, 6, 7 points. So at most, that's 7 different x coordinates, and at most it's 7 different y coordinates. So all I have to do is kind of go from point to point to point to point and list only the x coordinates for each point. So this one is a finite list with only so many. The x coordinate for this point is -4. This one has an x coordinate of -2, then -1, then 0, 2, 3, and 4 are listed. For the range, remember the range is only the y coordinate, so we're going to go low to high, starting with this point. Like, what's the y coordinate of this point? -3. And as you kind of go from point to point, those are all the y coordinates. So yeah, a quick example where, if you only have a certain number of points, separate points, then you can list your domain and range like so. But this one, kind of like the ones on in the notes packet earlier, so the domain, is there a smallest x coordinate, like to the left? Like, is there a leftmost point, or does it go left forever? Is there a rightmost point, or does it go to the right forever? And what would be those x coordinates? Those are the two different ways to say from -2, from x equals -2, all the way to x equals 4, and everything in between. The range, remember, is there a lowest point, or does it go low forever? Is there a highest point, or does it go up forever? And again, you only care about the y coordinates of a possible lowest point and a possible highest point. So it's from low to high and everything in between, from 1 to 4, and then everything in between. Again, keep pausing the video as needed. Here's this example. Okay, a little bit of a plot twist. First of all, the domain. Domain is all the x's, like how far left and right does the graph cover? Is there a smallest x-coordinate, that is the farthest left, or does this graph go to the left forever? Does it go only so far to the right, and it'll have a largest x-coordinate, or does it go to the right forever? Well, I'll say this now. Part of your learning curve, or part of your handicap maybe here, your challenge, is that you probably don't have a whole heck of a lot of experience with a lot of different kinds of graphs. Kind of knowing how they're going to behave, right? So hopefully that's not going to get in your way too much, but like this graph is literally a V, and it's going to keep going. See the arrowhead? This is going to keep going in that direction in a straight line forever. And likewise here, it's going to go up and to the left forever. So this domain, it doesn't have a farthest left point. It's going to go to the left forever. It doesn't have a largest x-coordinate. It doesn't stop going right ever. It's going to include everything. So the domain here is all real numbers. Now the range, okay, low to high, it does go up forever. Like it's never going to stop going up. Like there's no highest point with a largest y-coordinate, but isn't this like a low point? Like it'll never go any lower than right there. So its lowest y value is therefore -2. So this would be like the set notation way, and this would be the interval notation way for the range. Okay. All y's greater than or equal to -2. In other words, -2 to infinity with the bracket. I don't know if I said this already in this video, but with the parentheses and brackets, you're always going to have parentheses for the negative infinities and the positive infinities, because think about, can you ever like include infinity in your, no. So it's just kind of like something you're always reaching toward. Like you can't include infinity. It's not even like really a number per se. Okay, here's this one. So again, what kind of graph is this? Like, do you have enough experience to know what the heck is going on? What's going on here is that it's starting like out of thin air right here. In fact, you might even see sometimes an actual point that's clearly shown like that, because this graph is actually starting right there, just boom, and then it's going to curve like this, and it will go up forever. It's going to go to the right forever, like faster. So it's going to the right way at a higher rate or whatever than it's going up, but it will go to the right and up forever. So domain, the smallest x-coordinate, the farthest point to the left, is right here. What is its x-coordinate here? 1. But then it's going to go to the right forever. It's not going to have a largest x-coordinate, so we're going from 1 to infinity. In other words, all x values, every number that's greater than or equal to 1. The range, remember, that's lowest to highest. You know what I mean? Is there a lowest point? Yeah, also here. This is also a low point. But for the range, we only care about the y-coordinate of that point, which is 0. So there's the two different ways to identify the two most, shorthand, like common shorthand, conventional ways to describe your range. Everything greater than or equal to 0. Number 5, just a line, okay? It's going to go up and to the right forever, down and to the left forever. So what do you think the domain and range for this one might be? feel free to pause the video if you need more time, but the domain is going to be all real numbers. There is no leftmost point. There is no rightmost point. Likewise with the range, there is no lowest point and there is no highest point. It includes everything. Number 6. This is the kind of graph that it's like a U shape. It will keep going up and to the left forever, as well as this will keep going down and to the left forever. So the domain. There's not going to be a leftist most point, so there's not going to be a smallest x value, domain value, but it's only going as far right as right here. It's never going to go any farther to the right than this spot. And what is the x coordinate there? Like, what's the largest x coordinate on this graph? Positive 1. Now the range, because this sideways U is going to keep opening up and down, like this is going to keep going up forever, down forever. There is no lowest point and there is no highest point. It's going to include all real numbers. Alright, one more example before, well, if you're at home, you're not going to be able to do the matching activity, but in class, following these examples, we're going to get even more practice by doing a matching activity in groups, but just FYI there. So this one is like similar because it's a U shape, but it's like a regular, it's like a, well, it's an upside down U shape. So now it's the domain where it's going to keep opening left and right forever. So there's not going to be a smallest x or a largest x. So the domain here is going to be all real numbers, but the range, okay, is there a lowest point or will it go down forever? It's going to go down forever. Is there a highest point with a largest y coordinate? Yeah, right here. It's never going to go any higher than this spot. And what's its y coordinate? Bam. Y equals 1. So that would be from negative infinity to 1. And by the way, maybe the final comment here, teaching point, with interval notation, you always put the smaller number first. So whenever there's a negative infinity, that's always going to go first. You can't get any smaller than negative infinity. So this is exactly how you would write it, from negative infinity to positive 1, and of course everything in between. Alright, so that's my, maybe my bestest effort to go through some examples and some teaching points where, you want to figure out the domain and range of a relation that's given to you with a graph. So that does it for this video.